We're going to talk about the phosphorus cycle. One must know is that the phosphorus cycle does not include the atmosphere. Doesn't include that. It includes the biosphere, the hydrosphere, and the lithosphere. So, a few things we have to know about this, and that makes this cycle the slowest because it depends on geologic processes. So reservoirs for this are actually quite slow. Now, we have assimilation and mineralization. They are two sides of the same coin. We have inorganic phosphate, which is converted into organic phosphate. Really, all this is phosphate that is now attached to a carbon atom, because anything that is organic is attached to carbon, right? Associated with carbon. So, conversion of inorganic phosphate to organic phosphate by aquatic and terrestrial organisms into their body tissues, right? So, here we have this process right here. Producers, consumers, and then decomposers can either return this phosphate, this organic phosphate, to producers, or we can go through a process called mineralization. All right, mineralization, in which we convert this just back into inorganic phosphate by organisms that are active in decomposition. Right. So these decomposers will go through, will allow this to go through mineralization. Now, this inorganic phosphate doesn't dissolve, is not, how do I want to say this? Doesn't dissolve. We have sedimentation. Water insoluble phosphorus precipitates out of aqueous solutions in the forms of phosphate containing sediment. Okay, so really what this means is when we have our mineralized phosphorus, it gets washed eventually down here into our aquatic systems, our streams, our rivers, our lakes, and then our oceans as well. And this dissolved phosphate can continue through this process right here, which we call assimilation right here, right? And mineralization, assimilation, mineralization. But eventually, this some mineralized phosphate will not will precipitate out and fall as sediment. Now, this is why the process takes so long and why this is a major limiting factor for a lot of areas. Um, because once this sediment is down here, it requires plate tectonics to push this through our geologic uplift, even through new volcanic eruptions. This can enter back into our lithosphere, never to be seen again. So this phosphorus, if it gets returned into a solid, gets incorporated into a solid phosphate rock form, that's really great, but that takes millions of years, right? So we have sedimentation, and we have something called geologic uplift, where the sediment gets uplifted through geologic processes such as plate tectonics. It takes millions of years. And eventually, wind, water, ice, rain will break this down through a process of weathering. Okay, weathering is the term that we use to break rock down into smaller pieces of sediment. Erosion is not that term. Erosion means the movement of sediment. You must know the difference between those two terms as well. All right, erosion is not weathering. Weathering is when you break stuff down. Erosion is when you move these broken pieces away. And once they're moved away, they can go back into our phosphorus cycle right here. They're assimilated, they are mineralized. Here they are assimilated, they are mineralized. They go through a process of sedimentation, geologic uplift, and weathering. Okay, this takes, again, quite a while. These terms must be memorized. These processes must be memorized. Okay, and the only real difference between phosphate, inorganic, and organic is the association with carbon, because any organic compound must contain carbon.